Welcome back, Patriots. I am the Math Patriot, bringing you another lesson in the fun and exciting world of high school geometry. As always, guys, if you find what I'm doing helpful here, please feel free to like, subscribe, tell your friends. We're trying to get the word out as much as possible. The math does not have to be as hard as everybody says it is, especially this trigonometry stuff. If you mention this to your parents, to your grandparents, to just about any adult in your life, they're probably going to have a bad taste in their mouth about geometry. But the reality is, this stuff is actually pretty easy if you just follow it step by step, baby step all the way through. What I've noticed is that when I was taught geometry, my teacher went way too fast. Take your time on this stuff, do some practice examples, look some stuff up online. Don't go too fast on these things or you're really going to mess yourself over. Like I said in the last video, if you can write down those trig functions and if you can cross multiply and divide, then you can do trig. Okay? Now, first off, before we actually get into solving things, I want to go over the subtle difference between what we've done in the past for solving for a side, which is Pythagorean theorem, and trig. Now, what you've done in the past is things like this, where you have two sides of a right triangle and you're looking for the third. Now, if this is the case where you know two sides and you're looking for a third, that is a definite classic Pythagorean theorem. I can't spell Pythagorean. Pythagorean theorem problem, because that's our classic a squared plus b squared equals c squared, and then we move on from there. Now, if you'll notice, these down here aren't like that. In this case, I only know the length of one side. I know the length or the size of two angles, which is just the right angle and this one acute angle. And it's asking me to figure out what the last side is. Now remember, at the very beginning of this thing, I said that trigonometry, the purpose of it was to find a relationship between angle measures and side lengths. And that's what those trig values or trig ratios allow us to do. So, first thing, we're going to be using our calculator today. Whatever calculator you're using, whether it's a TI or your iPhone calculator, I don't care. Just make sure that whatever your mode is, make sure that you're in degrees. We're not going to be touching radians. And there's too many calculator variations on there for me to give you a tutorial. Just figure out what yours is. Google it if you need to. Talk to a teacher. Talk to a friend. Figure out how to get your calculator in degree mode. And on mine, it's nice. It tells me degrees up there. So we'll come back to that when we need it. Now, first thing we're going to have to do on every single one of these, again, do this until you get good and solid on your practice. Let's go ahead and label our sides. We're going to do this one over here first. Hypotenuse is always across on the right angle. Draw that angle arc. That gives me adjacent. And then my other side on the other end is O, opposite side. Now notice this time I don't have a theta. I actually have a angle measure in there, and we'll account for that when we actually set up our equations. Now, let's see. The first thing was label your sides. Second is we got to identify which trig function we need, and you do that based on which side you know the length of and which side you're trying to find. Here, I know the hypotenuse, and I know I'm trying to find the adjacent. Well, H and A. Let's look at SOHCAHTOA. Oh, H and A are found right here. That means I'm going to be using cosine. So I'm going to set up my cosine equation. Now, last time we used cosine theta equals adjacent over hypotenuse. We're going to just fill in all the information that we know. So we've got cosine of, we don't have a theta for our reference angle, we have a 40. So it's cosine of 40 degrees equals adjacent over hypotenuse. Adjacent is x over hypotenuse is 13. Okay, so new step number one, or new skill, is just plugging everything in, which you've been doing substitution for years. You should be great at that. Now, we got to actually solve it. And people think this thing's kind of hard, but remember what I told you. If you can write this, and you can cross multiply and divide, you can solve. So here's what we're going to do. I can't cross multiply and divide because there's no fractions, or no fraction on the left. But remember, everything is a fraction. I can always put it over 1. Now, let's cross multiply and divide this thing. X times 1 is x. That gives me x equals, and then when we cross over this side, 13 times cosine 40. Now, always write the number out in front like it's a coefficient. Okay, 13 cosine 40. And now, here's where our calculator comes in. I've got x equals, I can run to my calculator and just type it in, 13 times cosine 40. Close that parenthesis, press enter, and boom, there we go. Now, always round to whatever the directions or your teacher tells you to. For now, let's just use 2 decimal places just to be consistent. So the answer is going to be 9.96. So x is approximately 9.96. And there we go. I'm done. Now, notice there wasn't even a divide step on here because the coefficient was 1x. Didn't even have to cross multiply and divide, just cross multiply. So, like I said, it's that easy. Now, let's go on. Let's try another one. Write down our sides first. Hypotenuse is over here. Adjacent is going to be here, and opposite is there. I know my opposite. I'm looking for hypotenuse. Well, O and H is sine. So, sine of theta is equal to opposite over hypotenuse. Well, plug it in. Sine of theta is 55 degrees equals opposite is 28 over hypotenuse, which is x. Okay, easy so far. Put that over 1, and let's cross multiply. Now you notice that on this one, x was on the top of, or in the numerator. Here, x is in the denominator. So this is going to have a slightly different solve pattern, but we still do the exact same thing. 28 times 1 is 28. X times sine 55. Remember what I said. This thing over here is always going to come out as a coefficient. So it's x times sine of 55 degrees. Now, I said you can cross multiply and divide. Here's a divide step comes in. We want to get x by itself, so we're going to divide both sides by this thing, by sine of 55 degrees. Now what happens is sine of 55 and sine of 55, those two are going to divide out or cancel out, leaving me with just x on the left. Over here on the right, sorry, let me get my head out of the way. Over here on the right, I've got 28 divided by sine of 55 degrees. Now I can run to the calculator and just type that in and see what I get. So, 28 divided by sine of 55. That's going to be 34.18. Well, it's not equal, it's approximate. 34.18. One more step, but it's not that bad. Just treat this entire thing like it's one solid unit. So this sine of 55 just keeps on going all the way through. And then at the end, you divide by it. No big deal. Okay? One last one, and then we will cut it for the day. Let's figure out what we got. I'm going to go ahead and write SOHCAHTOA just so that it's on the screen. Now, SOHCAHTOA, we've got to identify our sides. Here's hypotenuse, here's adjacent, and here is opposite. I know my opposite side. I'm looking for my adjacent side, so opposite and adjacent makes tangent. Tangent of theta is equal to opposite divided by adjacent. So tangent of theta. Now, actually, you know what? I made a mistake. I'm sorry. I didn't point this out earlier. Whenever I did opposite adjacent, I had my hand here and didn't notice. I had both angle measures. When you have both angle measures, pick one. I'm using this one. It does not matter which one, because remember in the last video I showed you that the sine of this angle equals the cosine of this one. It'll all work out. Just pick one. I'm going to choose to use this 65. Here's adjacent. Here's opposite. I could have done it the other way around. You get the same answer. If you don't believe me, double check it on your own. You'll get the exact same answer. All right. So theta, our angle is 65 degrees. Equals opposite is 182 divided by adjacent, which is x. All right. Over 1. Let's cross multiply and divide. And here we go. We've got the 182 times 1 is 182. We've got the tangent 65 times x gives me x tangent 65 degrees. Sorry, my handwriting got sloppy there. It says tangent, I promise. Then divide both sides by tangent 65. I'm not going to write it both times this time. I'm just going to go ahead and move it over to the other side. Tangent 65 degrees. So x equals, let's run to our calculator, 182 divided by tangent 65 gives me 84.87. It rounds up. Equals 84.87. Okay? There we go. Like I said, not that bad. All you have to be able to do is write your trig functions, cross multiply and divide, and you're ready to go. In the next video, we're going to take care of solving for an angle whenever the variable is in the angle position, which is not hard, just a little bit different process. Okay? That's it for now. And as always, guys, stay patriotic.